Hello and welcome to session 2 of NFTeasy, our fun little exploration of NFTs, in which I spend most of the time talking about tools, tips, and tricks, and almost none of it speaking about NFTs. So today, after sort of looking into two of our critical tools, being GitHub and Hardhat, Git rather than GitHub, the decentralized blockchain-like protocol that we use for source code management, and the framework called Hardhat that we're going to be using to write our smart contracts. Most of what we talked about in our previous session was the Open Zeppelin libraries. Right? So to remind you of what that is and what that looks like, I'll share my screen. This is the repository that we'll be working off as always. You can see that if you change your branch here from lesson 0 to lesson 1, you'll get the instructions for today's tutorial. And where we were last time, if you remember, is we had spent most of our time in our dreaded node modules folder in the Open Zeppelin libraries that we installed, looking at both the extensions and just general ERC 721 contract that they have written for us, and kind of reflecting on this incredible feature of the open source software ecosystem that we get to build upon the shoulders of giants, and that all of this work that has gone into not just writing the standards, which we also looked at on eips.ethereum.org, but actually implementing them in usable libraries that take one line in our terminal to download, and then you get all of the stuff which you can just inherit in your own smart contracts. And then the only thing that you need to do in your own work after inheriting the work of everybody else that has been, sort of generated from our collective experience of writing contracts in these open, public, and adversarial environments, and represents in some deep sense the collective consciousness of many tens of thousands of people who have been writing code and experimenting with different ways of organizing and different ways of agreeing upon not just the state of our network, but the nature of the ways in which we will collaborate. So we can just inherit all of that collective work, and then in our own smart contract, the only thing that we actually needed to do was write our own unique mint function for our NFTs. We're using a particular kind of conceit here, which is that our NFT is going to be a book. I'm going to make the Library of Babel. It could be anything. It's just that I was, as I say, feeling slightly heretical when I was putting these tutorials together. So here we are considering religion for machines and the language of God and all of these kinds of things. It sort of fits together somehow in my mind, and we'll take a look at all of that in the course of today and next week's tutorial. So this is kind of where we were, right? And what I want to do today is we've got an understanding of Hardhat, the framework that allows us to write smart contracts, test them, compile them, deploy them. We've got an understanding of the basic libraries that we can use, particularly Open Zeppelin. We've got an understanding of how we're going to manage our source code, and just how incredible Git is, the fact that it is content addressable, the fact that it is cryptographically linked. All of these ideas should be somewhat familiar for anybody working in a blockchain or in this kind of environment. So when people tell you that we're the latest cool kids on the block because we have content addressable stuff, remember that this was going on in Git from 2005. Today, right now that we've written our smart contract, I want to actually use the functions of Hardhat, which I've been talking about, which is compiling these contracts, testing them, and deploying them onto a network. because it's one thing, and it's all well and good to be able to actually write the logic that we would like to implement, so we can get our NFTs together and start building this infamous library. But we also need to make sure that these things actually compile down to a language that the EVM, or the Ethereum virtual machine, can read. We need to test them to make sure that they do what they say they do and nothing else. And we need to actually figure out how the hell do we deploy these? How do we put them onto the network that we want them to be on? How do we get what is on the screen now in my text editor onto Ethereum or any one of the test networks? Happily, these days, this is a little bit easier than it used to be, but it's still not a completely straightforward task. And one of the things that this yields, if you make sure that you're on mute, that would be good.
Well, yeah. Andy, if you co-host me, I can help you folks. Or I think we're good for now.
Cool. I'll do that in a moment. My Zoom will work, which is, there we go. Let me just co-host Vivek. There we go. Good. Thank you, Vivek. Okay, so it's time to actually write the code that is going to help us compile, test, and deploy our contracts, which is the point of this particular tutorial. And in order to do that, if you go to this repository, which is at kernel-community/NFTeasy, and it's on branch lesson 1, you will see that there is a little bit of an introduction to what we're going to be doing today, which is kind of what I've just talked about. The one thing that I'll discuss a little bit more is this notion of trade-offs as they apply to our thinking in kernel more broadly. And then if you scroll down a little bit, you'll see all of the dependencies that we're going to be installing today, and then some of the code that we're going to be using. Before I start talking about those dependencies, there is one thing that I wanted to touch on, which is that we're going to be using TypeScript today, right? And it's important, like the README here makes the point, right, that this is not the only way to write NFT contracts. You will find many, many tutorials online that teach you how to do this stuff. As I said last time, that will teach you how to do your own NFT contract in 20 minutes, right? And I told you that we were going to take 8 hours to do it, and that was very intentional, because when you learn how to do something in 20 minutes, taking all of these shortcuts, you don't actually really learn. You're not sort of seeing into the different kinds of trade-offs that every single step in the creative process makes. If you're an artist or any kind of creator, you're aware of this, right? When you choose to paint this particular part of the canvas blue, that is a choice to exclude every other color from that particular part of the canvas, right? And there are deeply intuitive reasons for why you do that kind of stuff that are informed by your experience, your background, your culture, your conditioning, your language, your being in the world. And the same thing is true of like development experiences. So what we're going to do today is like one way of doing things. It's not the only way, and it is going to become a little bit more opinionated because I'm very opinionated. But it's important that you understand there are other ways of doing this, and that I'm making very particular trade-offs in teaching you this particular method, which is exhaustive, explicit, and strongly typed, which is something that I'm going to talk about a lot today. And all of these things about being exhaustive, explicit, and strongly typed play into our notion of trade-offs, right? You will remember from the beginning of kernel in week 0, we were talking about the play of pattern, how everything exists in complementary opposites. In order to understand how to build so-called trustless protocols, we have to encode and define into the rules that run those protocols all of the different ways in which it's possible to cheat. And by doing that kind of thing, we can actually enable new environments in which we can come to trust one another more easily, right? And this is like the play of opposites is constantly in operation. Like when we think about value, it's the way that we think about value in the most interesting ways by defining everything that it's not, and then realizing that value is really just trust in clearly shared truths. I mean, the trust is based on this ability to encode all the ways that it means to cheat. And so it's always this interplay of opposites. The opposites don't exist in and of themselves. They are just the polar ends of a whole spectrum. And the whole point of like the thinking methodology in kernel is like, how do we, with humility, choose where we are on that spectrum between the opposites? How do we make the kinds of trade-offs that enable collaboration and creativity at scales not before possible? And if you look a little bit further on in module 4, following the trade-offs link from here, you'll see this beautiful brief from the IETF, which is the Internet Engineering Task Force. It's RFC 7282, I think, which is called On Consensus and Humming. Very famous brief written about rough consensus and running code. And I thought I'd just draw your attention to it. I'm not going to talk too much about it here because we'll talk about it in week 4. But it's a really wonderful little introduction to how deep this thinking about trade-offs really goes, because it touches on the very heart of the networks that we're working on here, which is about consensus, right? And what consensus really is and why we use it. Consensus is a tool, it's not a destination, right? And one of the things that we're really interested in here is about finding the most fertile directions in which to proceed, right? Because the constraints in software tend to be relatively low and obvious, and possibilities tend to be intimidatingly vast. And that's kind of what today is all about. There are literally 100,000 different ways to write NFT contracts. We're going to talk about one. And what we're trying to illustrate in the wider thinking methodologies of kernel, but specifically in this narrow and technical guild session, is that like the whole point about thinking in complementary opposites and placing yourself with humility is somewhere along the spectrum comes down to these 3 things, right? Resisting limiting visions, finding the most fertile direction, and allying with the right people, right? We're long-term people playing long-term games. We aim for low miscommunication, win-win interactions, and repeat interactions. And it's this understanding of consensus, which is not like something to bash other people over the head with, but is rather the most effective means that humankind has ever come up with in terms of defining what the most fertile direction is in which we can move in environments where there is no majority rule or violence, and in implementation by coercion, right? Which is what this particular little piece is talking about here. And it comes from a wonderful, wonderful essay called Fragments of an Anarchist Anthropology, which is linked here and which I cannot recommend more highly. David Grieber is the man who wrote it, and he's really incredible. So that's the kind of background to what we're going to be doing today. We're going to be talking a lot about types and trade-offs and why I've decided to make these particular trade-offs. I'm not saying that you should make the same trade-offs. What I am hoping to illustrate is just the way that I think about like the different trade-offs that I make when I'm writing these kinds of things. Or in this case, copying these kinds of things from the wonderful Holly Grimm, who we love and adore. Holly, if you're here or if you watch on the recording, thank you so much again, because you are the best. And in illustrating the kinds of choices that I make, the kinds of trade-offs that I make, hopefully it can help you find your own. That's really the intention with these things. So,
Andy, sorry, I have a question. You were saying there are multiple ways and to multiple trade-offs, but at the same time, how can we then figure out what's the most fertile way?
Wonderful. Yes, there are multiple ways, right? A good example of this is if we look at scaffold ETH, right? For instance, if you take a look at Austin Griffith's amazing repo Scaffold ETH, which is really becoming the kind of Ruby on Rails for Ethereum developments as in like it's very easy to use, very easy to get started, has all of the kinds of built-in features that you might need for a very simple application. You will see like another completely different way of approaching NFT contracts. Here is like a particular branch called Buyer Mints NFT for like a really wonderful way of making sure that you can launch an NFT contract where you upload all of the different NFTs prior to the sale, and then people who are buying them actually mint them in what is the word for this? It's just kind of slipping my mind. In a predetermined fashion. It's not the right word. But the point that I want to illustrate with this, right into your question, is that like the possibilities are genuinely intimidatingly vast, right? As it says in that post that I just showed in module 4. And so this question of like, okay, well, how the hell do we know even where to begin is a great one. And it's genuinely quite difficult to answer. But the best answer that I've ever come across is intention, right? That it really, this is why it comes down to like, what is your intention for building whatever it is that you're building? Because the design space is kind of infinite, and intention defines your own starting point, right? It gives you a place to start in the seemingly infinite space. And that starting point is what helps you understand where the next most fertile direction is, or the next most fertile step is. And then you can like find people who can give you certain kinds of insights about the differences between these approaches. So for instance, the reason that I bring up Austin's incredible repo here is because like if you're just kind of learning, experimenting, and you want to do something very, very simple, you're an artist, you have 10 paintings that you want to kind of like experiment with as NFTs and see if you can sell them. Like Austin's repo is a fantastic place to start because it has everything that you need, and you can genuinely get up and going in less than an hour. But if you want to do anything custom, right? If you have some unique kind of idea about what your NFT should be, how you want to sell them, how the process is going to evolve, how you're going to create some kind of community, what kind of culture you want to instantiate, you will find that when you use these kind of boilerplates repositories, and Austin's is the most complete and brilliant example of that, then inevitably, when you want to change something and implement your own logic, implement your own kind of thing, it becomes very, very difficult to do that with this kind of stuff. Because like when I change one thing in Scaffolding, I have to change a whole lot of other things that then depend on it. And then changing those things means I have to change other things in the repo. And it has this cascading effect, which like any dev on the call will know about. Like when you're using somebody else's templates, it's wonderful to get going. And like the first day is like, oh, this is everything that I need. It's so amazing. And then when you're starting to get closer to production, you're like, you know, I actually need X, Y, and Z, and changing X means that I have to change A, B, and C, and changing Y means that I have to change B again, and also D and F, and changing Z means I also need to think about G, X, and S. And all of a sudden it's so complex that it's difficult. And in fact, the time that you have saved in the first day with setting stuff up is eaten in 4 other days while you're trying to change a few things that you need for your own custom thing. Whereas like, if you want to, like do something that is, as I say, like custom, different, and according to your own kind of rules and logic, then it's kind of worth spending the 2 extra days, like setting up your own thing and getting everything into the sorts of alignment that you need for your specific projects, learning from and building off like what you can of others' work, but like really taking the time to kind of do your own setup because it saves time later on. So it's just about like, what is my intention with this project? What is it that I actually really want to achieve? Because that defines where I start. And then like, once I've started and I know clearly what my intention is, then it's much easier to go to Scaffold ETH or to any of these other tutorials that exist online to pick the best parts about how to do, you know, this kind of, Alan, you will know the word that I'm looking for. It's when we deploy a contract to an address that we know ahead of time. I can't believe I'm forgetting this.
Reminting something? No.
Yeah. I shared a link with Eleanor wants.
Not whitelisting, no?
No. It's
Running came in the chat.
Let's anyway, it'll come to me later. They're doing it here with the Biomints NFT stuff, and you can do it with create two opcodes. So I know how to do it from an opcode perspective. I've just forgotten the English word for it right now. But anyway, we'll come back to that. The point being that you can like cherry pick the parts that you actually need out of different repositories if you're doing like your own unique thing. If you're just like kind of learning and experimenting, Scaffolding is a wonderful place to start. If you're trying to do your own thing, maybe build like some of your own stuff using the base level frameworks like Hardhat and these libraries that we've been talking about. So I hope that kind of answers that question. The truth is it's very difficult, but intention is really what it boils down to.
Lovely. Thanks a lot.
Sure. Okay, so the first thing that I would like you all to do is make sure that in your terminal, you're in the correct directory, so that you're in our NFTeasy folder that we created in our last guild session. You'll remember that's the way to get there is to use CD if you're in Linux or Mac. The way to do it in Windows is dir directory, and drop into NFTeasy.
Andy, are you referring to upgradable contracts?
No, it's not upgradable, man. It's this is I'm referring to a particular opcode which allows you to do, it's not deterministic, but it's something close to that word. This is counterfactual contracts. That's what I'm really talking about. So counterfactual deployments is what they're doing here in Scaffolding. You know where the NFTs will be, and counterfactual deployments in general is when you know the address that you're going to deploy a contract to before you've deployed it. That's what I was really thinking about. Please excuse my momentary brain fart. Counterfactuality is fascinating. One of my favorite subjects, not for this guild session, but really interesting stuff. Used in production by many different teams, most famously probably the Uniswap team. But also like a lot of different people these days are using counterfactual deployments to make sure that their contracts are deployed to the same address across chains, for instance, which is really great. So like on Matic and BSC and Ethereum and all the test networks and XDAI, you can ensure that your contract gets deployed to the same place, which is really kind of cool and magical when you consider the size of the address space on Ethereum, which is 2 to the 256, which is more atoms than there are in the universe. So it's very big, and counterfactuality is really an amazing feature of this environment. But like I say, not necessarily for right now. What I want you to do is make sure that you're in your NFTeasy directory and run just the first line, this npm install, and we're going to be installing various different packages that we need for the full operation of Hardhat in our first line here. You can see that most of these packages here have to do with something called Waffle, which is dependent on something called Ethereum Waffle, which is dependent on or related to something called Chai. This is our testing framework. It's how we're going to make sure that our smart contract does what it says it does and only that. And then we've got Hardhat Ethers, which is related to the Ethers package, which is our Web3 provider, how we're going to get signers with addresses and interact with Ethereum-like objects from our local environments. And if you run that, it should start to sort of give you a whole bunch of these different warnings. And I thought that I would just spend a moment speaking, because we touched on this last session, saying that like here in your terminal is the entire story about open source funding and how broken it is. When people talk about, yeah, open source code and the economic model is really broken, all you need to do is npm install anything, and you will get these kind of deprecation warnings or like just straight up broken warnings. And it kind of points to the problem of incentives in the current open source world, particularly outside of the blockchain, but also there as well. You'll see that like, look, this library is no longer supported. This package is broken and no longer maintained. Request has been deprecated. This has been renamed to that. Somebody is still using test RPC, which like, if you know anything about the history of Ethereum, this is crazy. Like test RPC got renamed to Ganache 4 years ago. You know what I mean? So there is some package that we're installing here, which is still like referring to very, very old versions of software, to deprecated versions of software, to libraries that are no longer supported. And this is like, what you're seeing here is the stack trace of lack of extrinsic motivation in open source software development. We, as Sid so beautifully said last week, are relying on like the collective consciousness of so many different incredible people, but also like these people are not incentivized to maintain some of the software that we write. And so you get all of these like deprecated warnings and all of this other kind of stuff which is going on. And nobody like really, apart from crazy people like me, looks at like the npm install messages, but it's a whole story, right? It's a whole story about what has been happening in the open source world and the nature of these like gifts that are written by people and then kind of like left because there's no incentive to maintain it, to make sure that like it doesn't become deprecated or doesn't refer to other software that is deprecated. There's people that are looking for funding. Please support it. Please consider supporting us, or like, hey, hire me. And you know, it goes on, like you are missing peer dependencies. There's these optional dependencies and unsupported platforms, all of this kind of stuff that's going on. And then at the very bottom, you'll see, well, we've got 1,108 packages, which is terrifying. And for any kind of assembly or lower level developer, this kind of stuff is just everything that is wrong with JavaScript development in general. But it's kind of cool. There's 626 people that we're relying on just for these packages that we've installed. But look, you know, 118 of those packages are looking for funding, and 75 of them have vulnerabilities, 40 of which are high. They're severe vulnerabilities. Now, this isn't like a major problem for our work and for our project because we're installing them as developed dependencies. They're not going to be bundled into and compiled with our application. And so it's not quite as severe because we're just using them in our development process, and it's not going to like necessarily affect the security of anything that we write. But it is kind of like pause for concern, right? Like this is one of the trade-offs that we're making when we rely on open source software, and we pull down those things which are near to us and easy to find. Not only do we increase the complexity of our dependency graph, but we also introduce potential vulnerabilities that are very, very difficult to understand because I don't know exactly where these vulnerabilities are. And even if I did, I couldn't really fix them unless I got in contact, you know, with Henry Zhu and said like, look, buddy, we need to become the maintainer of 6 other open source repositories and make sure that this code stays up to date and bug free, which nobody really wants to do because there's not much financial reward or incentive in it. So it's kind of something to be aware of. And the reason that I'm kind of obsessed with this is if you click on this link for like the language of cattle auctioneers, it goes to a really wonderful video about Werner Herzog, who was kind of obsessed with with the language of cattle auctioneers. He actually put it into some of his films, and he called it the real poetry of capitalism. So I just want to play you.
Inspired the entire film. It was like a field of flowers gone mad, he said. A landscape of complete ecstasy and fantastic madness. They can be found in people themselves. 31 quoted in have now 75, 175, 175, 175, 175, 51, 75, Solma 31, 50. In How Much Wood Would a Wood Chuck Chuck? Herzog documents the rapid language of cattle auctioneers, calling it the real poetry of capitalism. He was so fascinated by it that he even included it in his feature film Strashak, which was.
So I'm kind of fascinated with this because like the language of cattle auctioneers is kind of like what you're seeing here. Like when your terminal does this kind of thing and you get these stack traces, it's too fast to sort of like follow all of it immediately unless you like sit like me and actually go back and read and be like, what is going on here? You know, what is the story? But this is kind of like the real poetry of cooperation, and it's kind of a sad poem at the moment, full of all of these pleas for jobs and funding and audits and security problems. And one of the great promises of open source software environments that have built into them financial incentives is a different kind of poetry, a different kind of collaboration or cooperation. And this is where you actually see it in action, not in some kind of abstract conversational sense in a junta, but it's like here in your terminal. This is what we're really talking about. So that's kind of what's going on. If you install the other two lines, you'll see that the next line here has to do with our Typescript dependencies. Typescript is something that I will talk about in just a moment. And the other line has to do with more Typescript dependencies specific to Node, which is the runtime environment for JavaScript that we spoke about last week, Mocha and Chai, which are the testing frameworks we're going to use today, Ethers, which is our Web3 JavaScript library that allows us to speak to the chain, and Hardhat.
We lost Andy. Andy, come
Wasn't
back
sure
to
if it
us.
was just my computer or not.
Yeah.
It might be because of the
All right,
downloads.
now to Vivek.
I don't think that one's gonna work this time.
Oh, damn.
Let's see. Someone might be able to better answer Juliet's question than I can on ethers. Is ethers for backend what Web3.js is for front end? I don't know if Sid or anyone else who engineers much more.
Yeah, it's a way to
ethers.
communicate to the blockchain. So you need a link to communicate the smart contract with your front end. So you use this Ether and Web3.js just to communicate, to make this link and make that everything that happens on the smart contracts will be reflected on the front end, and everything that you every action that you trigger on the front end will be reflected on the smart contract.
So basically, just to clarify, the ethers package would be to write to the blockchain, and of course, I would assume to like read as well. Whereas the Web3, JS package in front end would be to sort of read from the blockchain to be able to display it within your JavaScript files. Correct?
Yeah, it's a connection. It's a connection that you have to trigger the actions.
Yeah, cool. That's useful. Thank you, Paulo.
Please excuse me.
Justin. All good.
That's just my computer being my computer. So we're
we're good. We got there. Yeah, you're in the dependency. We got back through some Q&A and you're back just in time.
Wonderful. Let me carry on sharing my screen and hope that's we can continue from where we were, which is installing our TypeScript dependencies. If I disappear again, please forgive the RAM on my poor little computer. Hopefully I won't. These dependencies are just so that we can run TypeScript, which is something that I will explain now, and the reason for like why I choose TypeScript rather than just normal JavaScript, which is what we would ordinarily work with if we were using Hardhat or Truffle or Embark or any of the frameworks that we talked about last week. You can see here that again, like we're like peer dependencies, all sorts of problems. The same 75 vulnerabilities are still registering. We've kind of been over that. And then the other line here is TypeScript dependencies specific to what we're working with our project. Node is our runtime environment for JavaScript. Mocha and Chai are testing frameworks, which we'll look at today. Ethers and Hardhats. This is our Web3 connection library. And Hardhat is the framework, and there's a very particular like part of that framework, one of the plugins to do with type chain that we're going to be using. So while that gets installed,
so when I installed this line, it gave me a bunch of errors. It just says error code to resolve. Like it just lots of npm errors on the third install there.
Yeah, I also got a bunch that said npm version 6.x. You need to update to 8.0.
I think you can, guys, you can minus force it, and then it should go away. It just refers to some old dependencies that I'm not sure that is relevant for the session, but might be. We can get along without them.
Okay, so you either run this particular command with -- force, or because like I'm not like a huge fan of forcing things. I'm is it against my Wu way? You know, I mean, we never force.
Only because you said this is not for production. This is the only reason. But I agree with you completely. You're right.
The other thing that you can think about doing is I'm not sure what version of npm you have. You can see that I'm using 6.7.0. And perhaps like your npm version could be different. Mark, especially for like development purposes, there's a wonderful tool called NVM, which is your node version manager, which I highly recommend. And there's the this is great.
Yeah, so my npm is up to date. It seems I'm on 7.24.
Okay. And I'm not exactly sure what is causing that issue, and it might just be best to force it. NVM is like what I use, and it allows me to switch between different versions for different projects, which as a developer is really wonderful and very necessary. So for instance, like here, I can just use version 14 of Node, and it will automatically kind of switch over to using the latest version of Node 14 with npm updated as well, which allows me to kind of get past some of these issues. And it's the same, like I could use version 15 if I want to. Now I'm on Node version 15 npm 7.7.6. So this is a great tool, particularly for developers.
I'd skip over me then, because for some reason it's saying I don't have Node installed, but I remember installing Node.
Yeah.
Saying NVM doesn't recognize, so we'll just move on.
Okay. Yeah, just see if you can. The NVM install is pretty easy from that GitHub repository that I posted in the chat, and we'll come back. And if not, I'll sit with you afterwards, and we can just sort of go through it, see what the problem was. Yeah. So that is. Those are the three kind of things that we need. We need some stuff for like testing and connecting, then our TypeScript dependencies, and then TypeScript specific stuff for testing and connecting. That's kind of what those three steps have done. And the question is like, why use TypeScript? Well, TypeScript is, just for those of you who don't know, it's like a superset of JavaScript. So JavaScript is kind of like the most popular language on the web, as it was sort of one of the first languages that we used for like coding stuff in our browsers. And TypeScript extends its capabilities, right? So JavaScript is, as the name suggests, a scripting language, which means that it works mostly with functions. And TypeScript is object-oriented programming. So it takes that like scripting language and it turns it into dealing with like very well-defined, clearly defined objects. And the reason that that kind of thing might be interesting and important and why we like it is that like it provides us this notion of static types. So like when I declare variables or I declare certain functions, are actually kind of classes in my code, then I can be very, very clear about what those things are and what they're meant to do. And having, you know, object-oriented programming with static typing, interface supports, these kinds of things that TypeScript gives us, it means that whenever my code is compiled, it automatically checks the correctness for me and catches all sorts of bugs that I wouldn't ordinarily see. And those like little errors, whether they're typos or other things where I'm kind of mutating types with my functions, and I'm like taking a string and kind of turning it into a number without explicitly saying that, these cause errors in TypeScript. And it's really, really useful as a developer to be aware of what is going on at every step in your code, because then you can think explicitly and exhaustively about what you're actually doing. And TypeScript kind of requires that I do that, which is a little bit of a burden at first, but it actually becomes a great joy as a developer, because again, it's the kind of thing that, depending on what your intention is, it really saves time, because I can not only be very clear about what my different functions are doing and what kinds of objects and classes I have, but then like there's all sorts of like neat little modern help tricks that come along with that. In particular, in my like editor, I have like auto completion on steroids when I use TypeScript, and as a developer, that's very, very attractive. You know, you sort of get this the syntax completion, and the other like big thing which we're going to kind of look at today is that you get type safe interaction with smart contracts, which again, it just means that like you can be sure to a far greater extent that you're not passing malformed data to your contracts or expecting something from your contracts that it's not going to actually return to you. And so like these kinds of bugs are traditionally very, very hard to find when I pass like a number that is to a contract that is supposedly expecting a string, or the opposites, or I set up my code to receive a string when a contract is actually returning a number, or these kinds of things, which sound like very simple and stupid, but like it often happens, and TypeScript helps me deal with those kinds of things in a much quicker and elegant and more elegant fashion. I can be much more certain of the things that my code is going to do, which when I'm coding against smart contracts on a blockchain is a very attractive feature to have. So that's why we're sort of going to the extra effort of installing some of these TypeScript things, because they really help me understand what my code is actually doing and what the data that I'm working with at any given stage actually looks like. It forces me to sort of visualize what is really going on in any given step of the process, and that's like very attractive as a developer. So once we've installed those three things, we should then create a new file in our editor called hardhat.config.ts, some configuration file for TypeScript. So you can see that we've got our directory here looking good. We'll have a few more node modules than we did before. We've now got all sorts of types and type chain and tsconfig and all of that kind of stuff that we've just installed. And now in the root of our directory, we want to create a hardhat.config .typescript file, so that we can control what is going to go on in the rest of this guild. My VS Code is being very slow, if you forgive it. Better. And if you come into the repo, everything that you need for this configuration file, which I'll explain in a moment, is given here. So you can just grab it directly from the repo and put it into your config file and save that. So as you're doing that, I'll kind of explain just a little bit of what's going on here. This config file is used for any number of things in Hardhat, the framework that we're going to be working with. It's used to specify the version of the Solidity compiler that you're working with. It's used to specify what networks you're going to target for deployments. It's used to specify what kinds of plugins you're going to use. It's used to sort of import at the top level of your application the particular services or software that you will be using in deployment or testing or compilation. And it's highly extensible. You know, the Hardhat website has a whole bunch of information about like the ways in which you can use this configuration file. And, you know, I spoke a little bit last week about how much I appreciate Hardhat's approach to building software, which is to provide in a really clear, coherent, and simple way the underlying framework that everybody needs to do interesting things, and then build their software in a modular and extensible fashion such that it's very easy for other people to build plugins on top of it, because that's actually how you build community. You create open and extensible technical products. Community building starts and is seeded most in the most fertile way at the level of the engineering that you do. And this config file is like a great example of that kind of thing, because it's highly extensible and it's very useful in that particular regard. For those of you who are already developers, but perhaps are less familiar with TypeScript, you'll see that we're not using require statements to say what other packages are required for the functionality that we declare here, but we're importing them, which is just a slight change in the syntax between TypeScript and JavaScript. And you can begin to see here the kind of thing that I'm talking about when I say strongly typed, right? We're saying that this Hardhat user config is of a particular type. And you will see how that plays out, particularly when we write tests, but also in our deployment scripts that we're going to write very, very soon. And then the rest of the stuff is kind of self-explanatory for the moment. The default network, the network that we will use if we don't specify any particular option when we're deploying and testing, will be like the Hardhat local network. We'll be using a particular version of the Solidity compiler, which we've set to 0.8.6 for now, which is quite a recent one. You can add a whole bunch of settings to that, like optimization and all of these kinds of things, which we might do next week. And then we've defined our networks objects here, which for now only includes Hardhat, the default one, and localhost, which are really just the same. There's not a great difference going on there. For those of you who are curious about this thing, why you would have Hardhat and localhost, it's just a kind of curiosity of Hardhat, which is that when you run Solidity coverage, when you're trying to do coverage for your tests, which is something potentially we'll also look at today, Ganache Cly is what Solidity coverage, the tool, uses, and that launches its own network on localhost. So you need these two things specified, but you could, technically speaking, just get away with having the Hardhat network defined. And this little thing here of initial base fee per gas became relevant after EIP 1159 and has to do with the changes to the way that gas fees are handled in the network. And it was just like a random little hack that I think I loaded into, but have since lost, which is kind of if you're interested in why this is like this, you can go and read this issue, and you'll see that it was just kind of provided as a workaround for solidity coverage. So that's kind of where it comes from. It's not incredibly important to understand it, but you've just got a networks object that kind of defines which networks we're going to be using, and this exports statement makes it available at a global level in your application when we run different commands as we're about to do. So don't get confused. Don't feel too bad if that confuses you now. It'll become clear. But I see, Juliet, you've got your hand raised. So if you have a question.
Yes, thank you. So I see that you have a local host property that's empty.
Yes.
Isn't that something we should be filling so that we can tap into that program locally, or what should that property do there?
There are defaults that go along. If you just leave it kind of empty, it just instantiates that as an object. There are, you can define like what port you want to run it on and various other things, all of which are detailed in the Hardhat documentation. But just having it defined as an object is enough for now. The defaults that Hardhat has coded into the framework are enough for what we're going to be doing here. And in fact, like, you really don't even need that line. As I say, it's just in there because, like, later on, if we want to run solidity coverage to see how much of our tests, how much code our tests actually cover, we need it, but it's not very important. And the reason why we need it is this kind of like leftover thing that solidity coverage runs Ganesh Klai, which is an older version of like your local virtual machine. And yeah, so it's not for any like obvious logical reason that we have this thing. Yeah, it's just as a result of like some craft from history. Not a very satisfying explanation, I know, but that's why.
But that makes sense. I mean, if there already has a default and we can use that, then it makes no sense to keep adding there, unless you're doing something more complex. So makes sense.
Yes, exactly. Yeah. So if you were running your like local network on a different port for some reason because you had something running on 8545, which is what it defaults to already, then you could specify that here and this kind of stuff. But otherwise, the defaults should be good enough.
Or probably if you're using Docker as well, I would assume then you would have to like set up a different port there.
Yes, exactly. That's a wonderful point. Yeah, if you're using any kind of DigitalOcean, Docker, AWS, these kinds of things, and sort of any kind of virtualized hosts, then yeah, you would probably need to do some stuff in here.
Thanks.
That's true. Sure. Great points. Okay, so we've set up our dependencies for the session. We've created our config, and we've already, from our last session, if you remember, sort of written as I was going over, like the very basic smart contracts that we're going to start working with. So seeing as we've kind of written our config and we've already specified our compilers, we should be able to, even at this point, if I just use the right version of Node, we should be able to compile that contract and see that it does indeed compiled to what we need, as well as just taking a look at what actually happens at compile time and what we get as a result of this compilation. You will probably see, because I've been like testing this myself locally before the session, you'll probably have to like download the Solidity compiler at first. Don't worry if that's happening, it might just take a little bit longer. But while that's happening on your machine, you can see that as we compile, 3 new directories have appeared, which is type chain with a lot of stuff in it, the cache with just a JSON file, and artifacts, which has Open Zeppelin, build info, and our contracts, which are these sort of JSON objects, which is JavaScript object notation. The artifacts are what you would ordinarily be using in your vanilla JavaScript Hardhat setup to like test and deploy against, right? They contain all of the information that you need to both write tests against and to deploy onto whatever network you're going to be working with. The cache holds a whole bunch of stuff that is important for internal stuff in Hardhat. I'm like even a little bit scared to open. It's a very long JSON file that just has like a whole bunch of stuff relevant to Hardhat that's not like extremely relevant to us. It just helps Hardhat run future compilation, test, and deployment tasks quicker because it has all of the information there. The thing that I'm really interested in is this type chain directory, because rather than using the artifacts, which are just these kind of JSON blobs, you can see that it has like the contract name, where it comes from, and then the ABI, this application binary interface, which specifies every single function and event in the contract. So for instance, here you can see like the first thing in our ABI is the constructor, which has non-payable state mutability, that little sort of strongly typed feature where you have like payable, public, view, pure, internal, all of those things that you can tag onto your functions in smart contracts to specify their state mutability. And then like it goes through all of the different events and functions that are actually a part of this contract. So not just what we have written here, right? Because then the ABI would just be about the mint book, but this contract inherits ERC 721 URI storage, which itself inherits ERC 721. So all of the stuff that you'll see in here comes from ERC 721. For instance, the first thing that you see has it's got 3 different types of inputs. The one is an address and it's called owner. The other is also an address and it's called approved. The other is a type and it's called token ID. And then we see that, okay, this is an event and its name is approval. So whenever I issue an approval for somebody else to manage my tokens, this is the event that gets fired. It's kind of specified in my ABI. And you can like go down and see each of these things. But we're not going to be using our artifacts because we want to have strongly typed interactions that guarantee a certain kind of correctness and safety. And that's what installing this type chain stuff did for us, is it produces this extra type chain directory, which we get sort of like .d, .ts files from. And these all have the same kinds of things that you just saw, except they're strongly typed, right? We're encoding function data, we're saying what kind of type it is, and the nature of the interaction that we'll be having with it is also kind of defined there. Again, like you can go through, you can see these are very, very long files and they're automatically generated. It's not necessary for you to like read and understand everything. I just wanted to sort of like illustrate that here we're just going like an extra step along the path toward like genuinely safe and more well understood and guaranteed code, and that comes from specifying the type of data that we're dealing with at any given point in time, which again is like, it seems like quite a lot to take in, I understand, and the first time that I came across TypeScript I was like, really, do we like really need to do all of this additional stuff? And I think that if you're writing like a traditional web application, the answer is probably not, although like developers in the audience will know that like it really does actually speed up your development time, because it helps with syntax completion, finding little bugs, little typos, other things that are like really difficult to identify. But when you're interacting with blockchains, it really is worthwhile because this kind of stuff saves you from some really difficult to understand and find bugs. So that type chain directory is what we're going to use a lot. Yeah, so we've now installed our dependencies, we've written our config file, we've compiled our first contracts. We have all of the stuff that we need to test and deploy it. And so we're going to start writing the tasks that will help us deploy our contracts and test it. This is like another neat feature of Hardhat that, like, at first, if this is your first time seeing these kinds of things, it's going to seem like a little bit arbitrary. Like, why do we do these things in this particular way? But like, what I'm hoping to kind of illustrate as I go through this with you is how I think about separating out different pieces of logic and different approaches.
Give me, yeah.
Thank you very much. So, you know, like, what I want to try and illustrate is like why TypeScript is nice, because not only does it give us this strongly typed guarantees and type safe interaction with our contracts, it also allows us to kind of like structure our code in a really like logical and modular fashion, which is what I hope to kind of demonstrate now with writing these tasks. And the tasks that we're going to do are like to instantiate any number of account objects, which we will need for deploying stuff and writing tests, and then our actual task to deploy this contract. And so what we're going to do in our root directory that we've been working in is I want you to create a new folder called tasks. I think it's tasks. Just task. New folder called task with another folder in it called deployments. So we've got those two things. In the, if you follow along with step 5 here, the first thing to do is to create a task names.ts file in our task directory. So we have task names.ts. This is like a simple, it's like a configuration file, like a top level naming file for all of the different tasks that we're going to have. And here, the only 2 tasks that we're interested with at the moment are the accounts and the deployment task. But this is like, this is what it actually kind of looks like to write modular code from first principles, right? Like I have a file which specifies the different names of things that I'm going to do. And then like each different task, so for instance, deployments and minting tokens and transferring tokens and burning tokens and minting batches of tokens would have like its own different folder here. And I would specify its name and the type associated with it, which will always be a string in this particular file here, you know, and so it's just like, again, right now, when we only have 2 tasks, it's kind of like, why would you do this? But it just goes to like the logical structure of setting up your stuff so that like, as inevitably you want to do more and more things with whatever code you're writing, you can easily add onto it without incurring too much like logical overhead and having to keep like lots of different stuff in your head at the same time. What I was saying about like scaffold ETH, you know, like when I change some particular piece of logic to suit my custom needs, then I have to go and change 3 other things, and then I have to change 4 other things as a result of that. I have this like combinatorial explosion of stuff that I have to try and keep track of. And we know, just like neurologically, right, that you can only keep between 5 and 9, for most people, 7 things in working memory, right? Our RAM is very, very small biologically, and for most people, it's the rule of 7, right? It's a really fascinating thing to look into. If you're interested in this kind of thing, ask Alon, because the Israelis are the best at it. It's Daniel Kahneman and Amos Tversky, the sort of leading psychologists who looked into this rule of 7, thinking fast, thinking slow. And there's some amazing work for the Israeli army where a lot of this stuff has been implemented. So another whole like super interesting tangents. But the point is you can only really keep Andy? 7 things. Yes?
Yeah, can you check the chat once? Like some of us are having a few issues. Like I think Ben can speak up. I think we might have to slow down a bit.
Cool.
I can
Ben?
scroll up to.
Just can't access the chat. Okay, where are we, Ben?
Yeah, the NVM step. I'll paste Ben's message again.
Thank you very much.
I think that may have been in response. Go ahead.
Ben's on Windows, right?
Yeah, it's I'm holding on for dear life here, and I just don't, all the stuff installed automatically. Once I went into VSL, I did the bridge between Windows and Ubuntu, and then I opened a window within, or a terminal within VSL. It just worked. So beyond that, I'm not sure. I didn't see any of those other errors.
So it is working in VSL?
It is, for me, it's working, yeah.
Wonderful, wonderful. Okay, fantastic.
Andy, I don't want to slow things down if it makes sense to keep going, but I did have an issue where I ran compile, but like the artifacts folder was generated, but nothing was actually generated in it.
Same for me. And I think it's because I forced the npm when I installed the last dependencies that we installed, then I had to force it to go through. But then I got the error exactly the same as you did, but I haven't solved it. And yeah, I'm trying to figure it out too.
Yeah, so we're going to pin our hopes on Alfreda.
Yeah, when I was creating the directories, I did it within VSL as well. I didn't do mkdir or anything like that within the command line. So there could be some permissions or something in that. But as long as you do everything within VSL, then I think the permissions are taken care of automatically.
Sure, yeah, specifically in VSL. But Nate and Alfreda, are you on Windows as well?
I'm on
No,
Mac.
I'm on Mac.
But I have an
I'm on Windows.
I have an Ubuntu laptop right beside me, but my Wi-Fi connection doesn't allow me to have too many devices. But I will try to follow along and do it on the other computer. But it's same like yours. If I have too many Zoom and if I have too many things, then it crashes. Yeah. So therefore, I'm trying to do it on this one now.
It's so good to share the pain. It's wonderful to know that there are others who experience the same as ourselves, which is really what these things are about. Nate, I'm not sure. You said you're on Windows.
No, I'm on Mac.
Oh, you're on Mac. Okay.
Yeah. I'm happy to like follow along. We don't need to.
Okay. Cool.
I'm able to kind of like follow the concepts, but yeah.
And these kinds of things, like I can help sort of asynchronously in text in the NFT channel in Slack afterwards, and we can sort of figure out where they are, because like, this is the problem with making trade-offs, is that like different people's environments are different, and so then we end up in in radically kind of different waters, which is again significant of kind of this thing that we all need to make different trade-offs. Kind of proves that, but in a deeply frustrating way. So my apologies for that, but we can, we'll catch up in the chat and see if we can get those installs to work, and then you probably shouldn't have this the same issue. The one thing that I do want to check, it's okay if the artifacts folder is empty. Is the type chain directory there, and does it have stuff in it?
No, that's not there.
Okay, that's a problem, because we're going to be using that, and so yeah, like I'll come and we can talk in the Slack channel afterwards and see if we can solve those, or perhaps at the end of this.
Sounds good.
Okay, wonderful. So we were here and we were talking about sort of like logically structuring your code so that you don't end up trying to shove more than 7 things into your working memory at any given point in time, and that you make it easy for yourself to navigate to the different parts of your application that do different tasks and fulfill different functions, which is what we're trying to do by setting up our task directory like this. even though it seems a little bit strange at first when we only have these two very simple tasks. But we have our task folder. We've written our task-names.ts file. The other thing that we're going to put in the roots is the accounts.ts file. And you can grab the code for that also from the repository.
Andy, does it matter
yeah.
what you name the task folder? Because it says to name it tasks multiple.
Oh, it does say tasks. Did I just read that wrong? It does kind of matter. Yeah, let's call it tasks. Please forgive me that front. Makes more sense anyway, because we're going to have lots of tasks in here. So let's make sure we do that. We have our accounts, and I'll explain what's going on with this code in a moment. The last kind of task that we're going to need for this initial stage is our deploy task. So in our deployment folder, we can create a deploy.ts file. And again, the code for that is provided here, which we're going to look at. You can kind of copy it and then we'll talk through it. I think that I'll start with the accounts because it's a little bit easier to understand, and then we'll go into speaking about our deployment task, and then we're going to deploy our contract. This is very exciting for those of us who have not got stuck with empty folders or forced npm installs. The same thing as we saw in our config file is happening here. We're importing three different things. The first is this particular service from Ethers, which is called Abstract Signer. It's going to provide us with an account, right, to sign transactions, to deploy stuff. You always need some accounts to do anything on the chain, and the Ethers library or the Web3 library, they fulfill the same purpose. Ethers is just like a little bit better, smaller, and the API is kind of smoother for those of you who are interested in the difference. It provides us many different things, one of the most important of which for deployment and testing is this notion of an account that I can use to sign stuff. Prior to that, it was kind of like difficult to, because you have to like use your own accounts, and then like, where are the private keys and how do I make sure that I have the private keys accessible to sign stuff and not expose them to the world, mistakenly committing them to GitHub. More than one Ethereum developer has committed their private keys to GitHub, which is not a good thing to do, and is something that we will avoid in this particular guild slightly later on. But happily, for the moment, when we're just working locally, we can import the signer object. We're importing the task object from Hardhat itself, which we'll go and put that in our config file in a moment. We're importing the name of this particular task from where we defined it in task names. And then we're declaring, okay, we're going to start our task. Its name is called task accounts. Its description is that it prints the list of all the accounts that we have access to. And it is some asynchronous function which takes a bunch of arguments and that instantiates what's called the Hardhat runtime environment. It's HRE. Generally speaking, again, like, I don't want to go like too deeply into like this runtime environment stuff, but one thing that I will say here is that the really neat thing about Hardhat is that it provides this like runtime environment for you to do everything that you want directly kind of from your terminal without you ever kind of having to worry about it. But when you use TypeScript, you have to specify it explicitly because that's what TypeScript is all about. And so like, again, you know, you're forced into kind of actually thinking about what this runtime environment is and why it exists and how we use it. And at first that can seem like a lot, and it can seem like, why would I use TypeScript and have to specify the runtime environment rather than just using JavaScript and having access to all of it without thinking about it? You know, again, like perspective on this is, again, is that like it's precisely because you have to think about it. It's like a good thing to be explicit about the different parts of our code and what we're using, when and why. So I like the fact that you have to actually explicitly instantiate this runtime environments and then use it in order, for instance, here to get like the accounts. And here you can begin to see, right, like what strongly typed stuff is really all about. It says like, we're going to have this constant called accounts, and then we declare its type, which is a signer, and it's an array of signers, right? So we know just by looking at the code exactly what this thing called accounts actually is, which is an array of signers that we're pulling in from ethers. And like for any developer, it's really wonderful to be able to just like read the code and see, okay, like this is exactly what this thing is, because then I know what to do with it, how to write code against it, how to process what it returns, all of this kind of stuff. And all we're doing is just saying, okay, there's this like account stuff, it's an array of signers, it's some asynchronous function, which is dependent on whatever ethers has injected into the runtime environments, particularly like the signers and their addresses. And this task is going to log into our console all of the addresses that we have available to run the rest of our task. And that's, yeah, that's it. This is not a very important task, but like I wanted to kind of go over it because it is simple and it helps us understand the structure of what we're doing.
I got a question.
Please.
The console log, is it because we're using Hardhat?
Yes.
Or can you do that otherwise in your contract?
So this is like you can't console log stuff in Solidity, which is like there's been a huge point of contention ever since the beginning, right? That like debugging smart contracts is an absolute nightmare. It's much easier these days because Remix provides like really great debugging facilities. So if you go to remix.ethereum.org, there's an IDE there, an integrated development environment, which allows you to write, test, compile, and debug your smart contracts very, very easily. And like, I highly recommend it. And often if you're just like messing around with like smart contracts, learning, trying new things, Remix is the place to do it. And that's where you can like debug stuff much more easily, because you can't like console log stuff in Solidity, but you can, like the best way to do is to step through the opcodes, right? And to see where things are going wrong. And Remix allows you to do that very easily. But Hardhat also has console log-like functionality for your smart contracts. And it's much easier to debug stuff in Hardhat than it is in any of the other frameworks. So like, again, if you go to their websites, which is at hardhat.org, there will be something somewhere about debugging smart contracts and sorry, Erin.
I'm sorry. Oh, you're not boring. I'm just really tired.
Yeah. There will be something here, Juliet, about console, like the equivalent of console log for your smart contracts and debugging them. I'm not exactly sure where it is. I read it today when I was going over their documentation, but this is one of the reasons that we use Hardhat. It's just not like this here is like logging it in your own terminal. When you're running a Hardhat task, it instantiates like a JavaScript runtime environment, right? And it logs it there. You're not logging stuff out of your smart contracts, if that makes sense. I hope so. I hope it does.
Yes, thank you.
So this deploy task takes exactly the same form as our accounts task, except it actually does something more than sort of logging the array of accounts that we have available to do stuff with. We're actually going to like put this Babel contract onto our local environments, right? So we import the same two things, like this task from our config file, assigner with address from ethers, because we don't just want some kind of abstract signer array. We want a specific address because we're going to need that to deploy any contract. It has to come from some specific address. And then again, we say, okay, we're going to instantiate our task. It's called this. We describe it as saying, oh, it's going to deploy our contract. It's pretty easy. And a little extra step here is we're going to sort of set an action, which is again asynchronous. It takes some args and it instantiates the runtime environment. We are going to declare our first variable, which we're going to call deployer, and it's going to be some signer with address. It's the type associated with this thing we're calling deployer. And you can see that it makes sense, like later on down in the code, that this is the thing that we're going to use to deploy our contracts, right? Makes sense that it would be a signer with address. We're going to instantiate our network and sort of log whatever name it is, whether it's local. If it's Hardhat, it actually comes up as unknown, or if it's Rinkeby or Coven or mainnet. And then we're going to make sure that we know the address of our deployer. We're going to use our type chain directory to pull in all of the information that we need about our factory. And I'll go and take a look at this thing now so that we understand kind of what's going on in this particular line, or these lines of code. And then we're going to deploy it, right? So what is actually this thing that we've imported from our type chain directory called Babel factory? If you go and take a look in here, this should seem very, very similar to what is in your artifacts folder in the JSON file, except it's just strongly typed, right? And it has exactly the same kind of things, input, state mutability, and type, but you'll see that like it's got these other fields called indexed and internal type, right? Particularly the internal type. And this is like what gives us that type safe interaction with smart contracts, that we can be sure like this is exactly what it is that we're dealing with and how. So it's exactly what you see. It's the same ABI that you see in ordinary like JSON files from any kind of compilation, but strongly typed. And that's attractive for sort of all of the reasons that I've been talking about. And we're using, you know, I mean, like, again, if you're a developer, you should be aware of the await keyword, the fact that it's asynchronous. We're instantiating our runtime environments. We're using ethers to go and get the information about this contract factory. We're going to give it a name. We're going to make sure that it's like passed information about the externally owned account that is deploying it. And then we're going to use this particular function, which comes from the runtime environment to deploy the contracts and to make sure that it is deployed. It's just like some Hardhat specific syntax there. They have these pre-set tasks available to make our lives easy, so that we can just call .deploy, .deployed to both deploy the contracts and then to get its address back, basically.
And sorry, as a reference, this works because we already compiled the contract called Babel. So that's how it's able to find like get contract factory in the Babel name. So we always compile first, then run through the deployment, correct?
Yes, yes, exactly, exactly. You have to compile first in order to have like the stuff that we really need to put on the chain. And if you didn't compile first, you would get a runtime error at that line saying this thing doesn't exist. Because this factory in our type chain directory is only produced at compilation time. So in order for this file to succeed, then you need to have run the compile first. And if you don't, that's like the wonderful thing about TypeScript, right? Is that like it doesn't fail silently. As a developer, like again, you know, like one of the things that is the worst thing that can happen is if something fails silently. Like, I don't even know where to begin looking for the problem. Whereas if I have like 100-line stack trace, it's annoying, don't get me wrong, but like at least it's a lot better that I can go and like find where the potential problem is. And TypeScript does that for us, right? It'll say like, if I don't have this, if I haven't run the compile thing, I'll say like this line is referencing some import which doesn't exist. The last thing that we need to do before running our actual deploy is just make sure that these, if you were sort of following along, this particular line shouldn't make a huge amount of sense because we're, I mean this line here rather, sorry. We're importing this task from Hardhat config, but our config file doesn't have anything to do with these tasks. So we just need to make sure that both of these tasks are defined in our config. And that means we've wired everything up and we have everything ready now for actual deployments, which is really quite exciting. And we're going to be using our local network, right? We've set our default network as Hardhat. It's just running locally. It's a local JavaScript virtual machine. And if you run npx Hardhat deploy, you should be targeting this task. And if all has gone well, we will see the logs that we're expecting, right? Which is the network name is unknown because it's Hardhat and it's some random number that gets assigned to it. We have our deployer address, which comes from like our ethers projects, Hardhat ethers in our known modules. And we can see the address locally that Babel was deployed to. So this is really like encouraging, right? We've got a contract that compiles correctly, and we have the tasks required to put this contract onto any chain that we want, right? Onto any network that there is. So again, like I know, especially if you're like new to this kind of development, this can seem like a lot to take in at any one time. I appreciate that. But it's really incredible because we're building here the basic foundations that we need for any kind of contract on any kind of network, and making sure that the nature of our interactions with those contracts, both in terms of compilation and deployments, are guaranteed to be type safe, which is something that I really value, having written a bunch of contracts in my life and struggled with sleepless nights, about did we cover everything, and are we going to wake up tomorrow and find our contracts have been hacked by some arbitrary thing that we didn't think about when we were building all of these particular aspects into compile times, and did we deploy it correctly and with the right settings and all of this kind of stuff. I know that it is a lot to think about, but as I say, the intention of this guild is to give you the foundations, underpinning, and the scaffolding to really kind of like write your own things and understand them. So if you want like pre-built scaffolding that will come and make it very easy to build, like a very tall building, Scaffold ETH is a great place to go, and Austin has made some genuinely incredible things there that I love and adore. If you want to kind of build your own stuff, consider this kind of approach. The last thing that we need to do in this session is tests, and those will take like a very similar form to our tasks. They'll just be fulfilling a slightly different function, which of course is to make sure that what our contract says it does is what it actually does, and that it doesn't do anything more. So we need to create a new test directory and put a file in it called babel.test.ts. And if we do so, there's our new test directory and a new file in it called babel.test.ts. And this, again, you can just grab the code from here and paste it in your new file. And we'll we'll have a go at testing it in a moment once I've kind of explained a little bit about what's actually happening here. So as you're doing that, you'll see that there are some things which are familiar from the task that we just looked at. The first is this import signer with address from the same Hardhat ethers service. Then we've got importing like our factory, and we're also importing like the contract definition itself from our type chain directory, just like we did with our tasks. We've got ethers again, which is what's providing us, in terms of the JavaScript side of things, access to the VM or the various different networks that we might want to deploy our contracts onto. And then this thing called Chai. And Chai is a testing framework that is very widely used across many different JavaScript applications, not just within blockchains, but it has been extended to what we installed originally, which, if you remember, we didn't just install Chai when we did our dependencies here. We installed Ethereum Waffle and then the Hardhat Waffle thing, which kind of depends on that, written specifically by the Nomic Labs team. So we've got Chai underlying everything and Waffle on top of it, and the Hardhat specific Waffle stuff on top of that. And Chai is this wonderful like JavaScript testing framework used by lots of people, not just blockchain developers. And you can see that it comes in sort of like, it supports sort of three critical concepts for when you're testing stuff. You have kind of should statements, you have expect statements, and you have assert statements, which just test your code in different kinds of ways. And in each of these things, you have the same kinds of stuff which is like available. So, when I'm testing a variable, like I want to, for instance, what we'll do now is like test that a book was minted, and it should be equal to 1, or it should have a length of this, or it should have this kind of property. The same thing with like expect, how we expect it to have this kind of property, and expect it to do certain things, to behave in certain ways. And assert is just like, it absolutely has to have this kind of thing. A lot of this has to do with what people call TDD, which is test-driven development. I don't know how I mean, Paolo and some other developers on this call, Sid, as well, like test-driven development is really wonderful. I haven't been teaching it in this guild because, like, honestly, I'm not proficient enough at it to feel comfortable kind of teaching others. But like what it means is that like you write your tests first, and then you write code to conform to your tests, and that makes your whole process even more explicit, exhaustive, and safe. And so it's like held up as this kind of shining light in many developer circles as the way to write kind of space shuttle safety levels of code. It's also like very difficult to do, which is just my personal limitation and perspective of the thing. There are some incredible, like if you really want to be a shadowy supercoder, I think that learning about TDD is like one way to get there. Yeah, it's not the way that I develop, but I do really value tests. And if there are other developers on the call who have more insight into TDD and how valuable it is, it might be worth sharing. But it's a wonderful ideal. I know very, very few people who live up to it.
Yeah, so it just teaches you, like, I'm not sure about how it's done in the blockchain space, but it just teaches you to think like an attacker. Like you become an attacker and think of all the ways you can screw up your own code. So that's a different way of thinking about programming altogether.
Wonderful, wonderful. Thank you. That's a really fantastic contribution, yeah, Sid, because it speaks again, like in the other Solidity, the Ethernauts guilds, we've kind of been talking about like how there is this complementary opposite at work when we're writing smart contracts to attack other smart contracts, because there's only like in thinking like an attacker can we come to genuinely understand and intuit from first principles what this language of defense is really all about, the kinds of patterns that are truly kind of robust and resilient in these adversarial and public environments. And it's fascinating, I think, just from like a wider perspective to consider the fact that like in thinking like an attacker and thinking not about like what should my code do, but what are all of the ways in which it can be attacked, I can actually write much more resilient and robust code. It's another like wonderful technical example of this complementary opposites that we've been talking about for some weeks now. So thank you for that. So wonderful, wonderful addition. You can see that with Chai, we're going to be using the expect stuff. We're going to expect certain things to happen because that's just the way that this particular guild is set up. You could use either should, assert, expect. It's just that's this is kind of what I'm most familiar with because it was the way that I happened to learn at the beginning when I didn't know that there was different ways of writing Chai. And we declare a few things that we're going to need in our tests, right? The Babel factory is just so that we can deploy the stuff in the same way that we did in our deploy task. Babel itself is like the contract that we'll be testing stuff against and expecting things to happen on. And then we have a deployer address, just like we did for our actual deploy task, because we will need to like deploy these contracts in our local environment to test whatever happens with them. And then some other accounts. And these other accounts are what we use to like test whether our code does actually protect against the things that we expect it to protect against. You have like an other account or an attacker account. So these kinds of things are very common when you're setting up your tests. We also have to define a the zero address, which is 0x0000. The reason for that will become apparent in just a moment, but just believe me that we need it. And then if you do, we'll end this guild session by talking about black holes, which is very exciting. And then like test code is actually really beautiful to write, truly, because it says exactly what it does. And so you have these kind of, Chai works with these describe blocks. So you have to describe what you're expecting and then write the code that you think will cause those kinds of things and check that it behaves in the way that you expect it to. That's kind of the conceptual framework for tests. And we're going to describe, the first thing is that we're like working with our Babel contracts. And then you can see that like within this describe block, we're going to do a number of different things. We're going to like speak about like deployments of the Babel contracts, or we're going to describe the minting of tokens in our Babel contracts, or we're going to describe any of the other functions that we expect it to fulfill. And then within each describe block, we're going to say it is expected to have this name and symbol, or it is expected to mint this token when I call this function, or it is expected to do this, or it is not expected to do this particular kind of thing. So you just have like describing what you're going to do, and then it should blah, 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 and you write the code. And then it should not blah, 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 you write the code. So like testing is, it's really quite intuitive actually from a developer's perspective, and it's incredibly satisfying. Like just on a psychological level, I don't know if anybody else feels this way, but like when you write tests and they pass and you have like these green ticks in your terminal, it's just like the best feeling. It's just like, like all is well in the world and the tests are passing. I can go and have a real cup of chai and everything is just wonderful. So anyway, we've got our first describe block, which has to do with the contract itself. This is just sort of shorthand syntax for an asynchronous function. And then we're saying before each describe block that follows this, we've got to do some stuff, which in this case is just like instantiating our deployer and our other accounts and deploying the Babel contract, right? And in fact, in this deploy, in this before each block, we already have one test, which is that the address that Babel is deployed to should be some proper address. And this also ought to give you like a little bit of pause for concern, because like if you look at the Babel, the Chai homepage, you know, like they have like to be and to equal and to have length of and to have property, but they don't have anything to do with what we're testing here, which is to proper address. So like where on earth does this come from? And the answer to that is that it comes from Waffle, which is like the extension of Chai that we use in Ethereum. And it's all wonderfully documented here, but you can see that like what Waffle does is it extends the testing declarations of Chai. So instead of just have to have length of, or to have this property, or to be you can get a whole bunch of stuff to do with Ethereum based things, to change token balance, to be proper address, which is what we're using here, to change ether balance, to revert with message, to be called on contract arguments, to be called on a contract, to emit events is a big thing that we'll be working with in our tests. So all of this stuff you won't find in Chai itself, but it comes from Waffle, which is why we installed it earlier. And that's our first kind of test. Any expect statements is going to run a test. And that before each block will run before each describe that we write, each describe block that we write. And the first thing that we're going to test very simply is that like this contract does indeed deploy correctly, which we've kind of like seen, like, yeah, it seems to do that here, but we want to be sure, right? And we want to be sure that it's instantiated with the right things from our deployments. And yeah, so like this is it's pretty self-explanatory here. Like it's just that you have this, it has expected name and symbol and some asynchronous function as with everything in blockchain, and we expect that if we like call the public name getter function on Babel, it will equal Babel, and if we call the symbol function, it will equal lib. And this has come from the fact that we are calling those two things here in our constructor when we deploy the contract. Right? These two, we're defining it here in the contract itself. It's not, you know, we could deploy this contract with arguments and then we would have to like adapt our code slightly, but like this is defined in this particular example at the contractual level. And so because like the name is being set to Babel and the symbol is being set to lib, we can check those two things because they're public variables, and we can call them by looking at the contract and calling the name or the symbol public get function, and then we expect it to equal whatever we put in that contract, which in this case is Babel and lib. So that's all that we're doing in our test function for the moment. And if you have this all sort of set up in your test folder under babel.test.ts, you can run npx hardhat test, and if everything is behaving correctly, we should get one passing test, which is incredible. It's this it block is kind of what actually kind of prints these passing tests in our terminal. Even though we are like double checking ourselves there, that doesn't get printed into the terminal. It would just cause an issue if it wasn't true. We'd get a warning in our terminal. But it's the it blocks which give us those neat little green ticks, and you can sort of test multiple expectations within like one block, which is what we're doing there. And the only other thing that we did for this particular session here was write one other block to test the minting functionality that we put together for our particular Babel token. So if you grab that and put it below your deployments described block, you'll see that it has the same kind of structure. It's just that in this minting block, we need a few other things. We need some kind of token ID that we're going to pass to our mint function, and some kind of token ID which we're going to use to test our mint function, and some kind of URI, this universal resource indicator, the image or data, the metadata associated with our NFT. And in this case, we're just passing an image stored on the kernel community websites. Generally speaking, you know, in production, we'll put this to be an IPFS or an Arweave link, but just for testing here, we've put the kernel heart because that's kind of cute. And we've written one more test, which says it should mint a new book when anyone calls it, because it's a public function. If you look at our mint book, it's public, so anybody can call it. And whenever anybody calls it, passing in the address that they want it to be minted to, and the token URI where the metadata lives, then it should mint a new NFT. Right? And that's what we're testing in this particular block here. And you can see that it takes a specific function, right? So it's some asynchronous function. And we're going to expect that when we connect to our Babel contract, and this connect is like a wonderfully useful part of Waffle. Previously in like earlier versions of Truffle and Embark and some previous frameworks, it was like really difficult to, as I say, instantiate your account objects, make sure that your private keys were accessible without like being in places that might expose them to the public, and then like make sure that those were the specific accounts that you were signing stuff for your tests. So this like dot connecting is just, it's the greatest little piece of syntactical sugar. Like, thank you to whoever wrote it. And we're just saying we're going to connect our contract with our deployer address, and using that address as the context for interacting with our contract, we're going to call the mint book function. We're going to say that the address of the reader is this other person that we instantiated up there. And we're going to pass in the token URI, which we declared there. And we expect that when we connect to our contracts with the deployer address as our context and call this mint book functionality with these parameters, it is going to emit an event called transfer that contains arguments that include the 0 address, the other address that we passed into it, and the token ID that we established there, which is just number 1. And like, where does this event actually come from, right? Because if you look at our contracts, we're in this mint book functionality, there's no event declared, right? So like, how do we know in our tests that like there is going to be an event emitted and that it's going to have these specific arguments? Well, we have to follow the chain of inheritance in our contracts, right? And we know that that Babel is an ERC 721 URI storage contract, and that's, if we bravely venture into our node modules folder again in our token, we saw that like this ERC 721 URI storage contract is itself an ERC 721 contract. And if we go into our ERC 721 contract and look for the mint event, for the mint function, we will see that it does indeed, here is where the event is emitted from, right? This makes sense. This is what's actually going on, like in our, you can see that like this is the function that's being called here, right? Like we're calling _mint. And it's actually the mint function in our 721 contracts that is sort of operating when we call mint book. And it's emitting this transfer event, and it says that the token is coming from the 0 address. It's being sent to whatever address is passed in, and the token ID is going to sort of be incremented by 1, right? And that is like all you kind of need to understand why this test is written in the way that it is. And if you save this file now and run npx hardhat test again, you should see 2 passing tests, hopefully. Okay, so that gets us close to the end with 5 minutes to spare. The last thing, as I said, if I got there in time, which I have, is the 0 address. Like, what on earth is this thing about? Why is it that in our 721 contracts,
Hello, Polo.
The new.
Hello, Andy.
Yes.
So sorry to cut it short. I have a question, and it's the kind of personal, and so the question goes this way. Let's assume you are my potential employer, and you have me and another person, contesting for the same post, for the same position, and I'm a kind of 90% good at what I do, and the other person is 70% good, at his own state. But in my own, I don't write tests. I do other things. My tools are clean, but I don't write tests. But another person that is 70% okay, based on assessment, includes tests in his code. I want to know who would you pick?
It's a difficult question to answer because I don't employ people. Is the honest truth, right? Is that like I think that's what these kinds of environments allow for is different and more creative kinds of collaborations, right? So the people that I tend to work with are like not looking for like employment in the same sense as you would traditionally do in a corporate organization, and it's certainly not through assessment, right? Again, like the people that I have worked with and have enjoyed spending the most time with and have done the most projects with have been those who actively like help me in the work that I'm doing and write code in ways which I couldn't have imagined, or who like have the courage to build their own stuff, right? Like that's one of the things that I'm kind of constantly like looking for in like developers, other people that I work with, is like how like have you built your own things, and like let me look at those, especially if they're open source, right? Because like if you've open sourced the stuff that you build, it's like highly significant of the kind of person that you are and the way in which you work and collaborate and the nature of your understanding of like control and ownership. And secondly, it speaks to a particular kind of humility, right? And that's like ultimately what I'm really interested in people that I work with are like, how honest are they and to what extent are they humble, right? And this is why it's important to have like written and built your own stuff and to have open sourced it, because if nothing else, it is an exercise in humility. Because you realize how limited and dumb all of us are, because there's always somebody else who's written much better code than you, and there's always some bug in your code that somebody else will find, which was like really dumb and stupid and you should have seen, but you just didn't. And it's that kind of mindset which actually allows us to work together and learn from each other, right? That like in these corporate environments, which are premised on assessment and on 70% versus 90%, it's this deeply competitive mindset that is not about how can I help, how can I assist, what can I learn with you in order to implement something which doesn't yet exist. It's just, what do I need to do in order to get the mark that I need to find myself, like a stable income. And I don't really care what I do as long as I just like have the job that lands me a nice car and a good house, right? And like just personally, I'm not interested in that kind of stuff. And I think that a lot of people in the Ethereum community specifically, but I can't speak for all of them, have this kind of attitude, right? That like, we're not interested in assessing people. We're not interested in how good your code is really. Like what we're interested in is, are you honest and humble? Because it's those two things that allow you to acknowledge how little any of us knows and to have the kind of mindset which is genuinely open to learning new things. And that's kind of like unspoken principles that are operative across like a large part of the ecosystem. Not everybody. And like there are specific companies that like, if you write really good code and you have like clear tests and you pass their developer assessment, they'll probably hire the person who gets 90%, because like that's the nature of assessments, right? They're set up such that you can quantify the skill of some person, and then you use that quantification to find the so-called best person, right? If you're in places that are trying to assess you, then it's generally speaking going to be the people with the highest marks. But it's certainly not how I operate. And I think that a lot of like open source software developers and companies also have these other things in mind, which are much more about, as I say, honesty and humility. And we can tell, you know, that's the really interesting thing, is that code is so honest. Oof, there's nothing more honest than somebody's open source repository. I know that the developers in the audience know what I'm talking about here, but like a lot of the best developers that I've ever interacted with are reticent to open source their code, not because of some financial arguments or because of you know, like extrinsic motivation versus intrinsic motivation or fame or fortune or any of these things. It's that seeing your code is like seeing how you think. It's like it's a poem, right? Like it's when I read somebody's code, I have really deep insight into the way that their mind works. Very vulnerable. Anyway, so that's, you know, like I think a lot of the ecosystem works along those kinds of lines. It's like, what have you built? Where is it? Can I look at it? And you know, has it humbled you? Because we've all been humbled, oh my God, so many times. So I don't know if that answers your question usefully, but I hope so. Anyway, it does also kind of bring us to the end of this guild session. The last thing that I wanted to talk about is that like there's no standard there's no specification in either ERC 20 or ERC 721 about like where tokens come from when you mint them. And so as a kind of just industry-wide adopted principle, everybody like mints them from the zero address. Doesn't mean that they actually come from there. That's just the sort of informal standard that everybody uses. And the zero address, therefore, is kind of like the black hole that gives form to the entire Milky Way galaxy that is the Ethereum universe and beyond, which is really interesting to think about all of these tokens and NFTs emanating from the null point, which is kind of something that I really enjoy thinking about, but will not burden you with further. If you would like to speak about Hawkins radiation, this kind of stuff, I'm available for it some other time. But that is types testing and tasks in Hardhat. I know that it's a lot to take in. I'm sorry that a lot of people had struggles with the NPM modules. As I say, it's significant of the problems with the current open source funding and working models. I hope that you'll forgive me for choosing the trade-offs that I did that didn't necessarily work out in your environment, but that's kind of how it is. So yeah, are there any questions, comments, radiations from other black holes? Does anybody have anything to say about Sagittarius or some kind of neutron star, pulsar burst, quasar, anything? If you do, please speak now or forever hold your peace in endless space.
I just have a question when this recording is released afterward on Notion, Vivek and Andy.
Yes, so I'll put it in like as soon as Zoom is finished processing it, which generally takes 10 to 15 minutes. And then we will upload it to YouTube in a day or two. And YouTube is where like we're archiving content for the moment. So there are playlists there where you can see the Outsmarting Contracts Guild and the NFTeasy Guild, have easy access to me kind of rambling on somewhere between strongly typed interactions with your contracts and Sagittarius, wherever else we find ourselves.
It's awesome, Andy. Thanks for this incredible conversation. I've been playing around with Truffle, but understanding a lot about Hardhat, it's very awesome. And thanks for this work.
Hey, it's no problem. And a lot of the TypeScript and type chain stuff for Hardhat is actually accessible in Truffle as well. You can use it there as like the same kind of plugin. You just import the module and you have this like similar functionality. So if you are familiar with Truffle and you kind of like keen to dance a little bit with TypeScript, it was voted the second most popular language in 2020 after Rust. Which, like, personally, I think it's just developers showing off. You know, they're like, we're really, really intelligent. So like Rust is definitely the most popular language because freaking nobody apart from like, I don't know, Daniel, like one other person in the kernel stack understands it.
Yeah.
And then TypeScript because it's also like supposedly got all of these benefits, which it does. But as you saw, like it has a lot of, it's difficult for people to install and these trade-offs are stark, which is I'm kind of reminded of in this guild. So yeah, worth thinking about.
Andy, and sort of going off of the Truffle sort of Hardhat debate, I'm also interested in like the Web3 versus Ethers conversation. Like what's one or the other better for?
I think that like the general consensus and specific people who have like slightly different opinions based on their contexts, the general consensus is that Ethers is better. And the reasons for that is that it's much smaller and the API is much cleaner. So it's just like, it's easier to install. It doesn't have as many other dependencies and like the API is like cleaner to talk to. I personally am like a really big fan of Rick Moo, the guy who like develops it with a few other people. He's like an exceptional person and developer, which I like appreciate. And he's put like a lot of time, you know, he's obsessed with like the size of code because it's kind of got to do with courtesy, you know. It's like an interesting like lower level aspect of like this developer subculture. Like back in the day, there was all of the stuff like the demo scene, you know, and like 64K demos and these kinds of things. I don't know if anybody here sort of remembers these like fun little aspects of hacker culture from like the early 2000s and before. It was like when you had limited memory prior to 2000 your machine, it was like really important that you wrote like really good code because then it kept, you know, the littlest amounts of space on people's machines. And that was kind of like, it was common courtesy, you know, to one another. And now because we have freaking gigabytes of everything, we're like, oh, fuck it. So what, I'll write a repository that's 250 megs. Who cares, you know? But
so it's probably more opinionated Web3 rather than Ethers. Ethers may be smaller and like leaner.
Smaller, leaner, and slightly less opinionated because it's also newer, right? Like Web3 was there from the very beginning, and so it comes with like a little bit of craft that like is just sort of not really necessary, but was like more historical. And it was like Rick built Ethers as it was like a passion project, you know, that he's really like involved in, and he has this like really successful Gitcoin grants, and it's like a really great community around him that supports him. Whereas Web3 was sponsored by the foundation and was like started by one guy and then picked up by another person and is now maintained by another person. And that kind of thing often results in slightly less clean code, which is kind of, it's not to say that Web3 is bad, it isn't. It's a good library. It's just that like Ethers is it's just like a little bit better. So
okay, good to know. Thank you.
Also very important that both of them exist, you know, because like decentralization at all of the levels that we can have is good. That's all. So so for the Web3 devs, like we love you. Please keep doing what you're doing. Don't stop. It's very important. Yeah. It's an important thing.
Yeah, thank you so much for this, Carl. I appreciate it. And I will write in the Slack channel so I get, if I have any questions, and get my errors fixed.
Wonderful, wonderful. Thank you so much. Yeah, we can investigate that on Mac. It should work. It should work fine on Mac. And so there must be something like easy that we can Let me not,
Yeah,
let me not jinx
can,
myself. There must be something that we can discover which will help us.
absolutely. I will throw screenshot in the Slack channel. I just I need to go out with my dog now. So thanks for
that
today.
sounded urgent. Yeah, attend to that. That'll be good. Dankjewel vir jou, Kassel.